Bonjour tout le monde. Good morning, everyone. I'm over here. We've changed the room around for those of you who are regulars. We've changed the room around and we'll be speaking from this side of the room. But good morning to all of you. Bonjour à tous. Je suis Antonia Mayoni, je suis présidente de la Fédération Sciences Humaines. Je suis ravie de vous voir ici, en si grand nombre aujourd'hui. I'm really honored to welcome you all here this morning in such a full house that we have on Parliament Hill. Today's event is a little different than other events we have, the Federation has in our Big Thinking lecture series, because we've partnered with the Partnership Group for Science and Engineering, also known as PAGSI. PAGSI works with 26 national organizations to represent the Canadian science and engineering community to the Government of Canada and to advance research and innovation for the benefit of Canadians. And for the last 2 decades, parliamentarians, their staff, and others have had an opportunity to engage with these leading researchers through 2 breakfast series. PAGSI has brought to you bacon and egg. Oh, wait a minute, that's bacon and egg heads. And the Federation for the Humanities and the Social Sciences has organized Big Thinking breakfasts. So as great minds come together, we have come together and bring you the Bacon and Big Thinking event. It's not only a Bacon and Big Thinking event, it's also something that's really important, which is to bring together researchers from both the sciences and the social sciences, which is something that's extremely important as we move forward in the kind of evidence to policy as well that we'd like to have as one of the things that comes out of these Big Thinking events. And today we're going to discuss something that we've actually lived through this winter, which is extreme weather and climate. Today is an actual mild day, but this is something I'm sure that has been top of mind for many people for many years. Canadians love to talk about the weather. In fact, at breakfast, that's what we were talking about, the weather. Not the scientific part of the weather, but the actual, how is the weather where you're from in Canada. Even though we love to talk about the weather, we know that there are scientific, social, and economic issues that accompany increasingly volatile weather here in Canada and across the world. That's why we've brought together 2 leading Canadian researchers to engage in a discussion about how government and communities can better plan for these changes and for extreme weather using insights from both scientific and social science research. Our 2 speakers today are Dr. Ronald Stewart, who is a professor of atmospheric science in the Department of Environment and Geography at the University of Manitoba. And Dr. Stewart's research focuses on extreme weather, precipitation, and regional climate. He's been a member of the Scientific Steering Committee for the World Climate Research Programme's Global Energy and Water Exchange Study, and he's led Canada's involvement in the International Union of Geodesy and Geophysics. He's a Fellow of the Royal Society of Canada and a Fellow of the Canadian Meteorological and Oceanographic Society. Dr. Daniel Scott is a University Research Chair in Climate and Society and Professor in the Department of Geography and Environmental Management at the University of Waterloo. He has worked extensively in the area of climate resilience, including leading research teams for the World Meteorological Organization, the United Nations Environment Programme, and the United Nations World Tourism Organization. Dr. Scott was also a contributing author and expert reviewer for subsequent panels of the Intergovernment Panel on Climate Change. Believe it or not, these 2 men are interested in climate not only from the science and social science perspective, but also because they both hail from Brandon, Manitoba, where climate is top of mind, all day, 24/7. So that's another fun fact. Cette table ronde sera animée par notre collègue Francis Pick de l'Université d'Ottawa. Dr. Pick is a professor of biology and environmental science and a member of the Centre for Advanced Research in Environmental Genomics at the University of Ottawa. She is also chair of the Bacon and Egg Heads Committee. Before we start, just a little shout out to thank SSHRC for their continued support of our Big Thinking lecture series. To NSERC, Canary, and the many other sponsors that you've seen on our sponsor slide for their continued support of the Bacon and Egghead series. I'd also like to thank our event sponsors, Engineers Canada and the University of Manitoba. Nous avons le plaisir d'offrir l'interprétation simultanée de cette conférence par téléphone. Alors, vous avez à composer le numéro indiqué sur votre table pour y accéder. Et si vous n'avez pas vos écouteurs avec vous, on a quelques-uns en arrière. Okay? I'd now like to invite Francis Pick to kick off this panel discussion, and there'll be, of course, time for the audience to ask questions following the panel. Francis, la parole est à vous.
Bonjour tout le monde. So I'd like to invite our speakers today. Ron, if you could sit over here. This chair here. Daniel will sit in the middle. So, well, it seems that Canada is just one big extreme weather event. So my first question is to ask Ron, our physical scientist, to define what an extreme weather event is, or what it means in the physical sciences.
Well, thank you very much. As what everybody knows, an extreme is something very far away from the norm. And the physical sciences that normally breaks down to two particular approaches. One of them is statistical. It may be an event of the top 5%, the top 1%, the top 0.1%, or the bottom. So that's one approach. You very often use that, for example, in precipitation, looking at days with some of the highest, if not the highest, precipitation on record. And sometimes you can turn that into a return period, the likelihood, how many years would it take for such an event to occur in the future. So that's a statistical approach. The other one is a threshold approach. Very often use this in terms, for example, temperature. If the temperature exceeds some particular threshold, that may lead to major impacts. So then you can talk about a heat wave that may occur above, say, 35 degrees Celsius or something like that. So that's another approach. It gets more complicated than that as well, because we also have things like compound events as well. It may not be just one event, it may be a whole series of them, as people in Atlantic Canada would tell you as well. So extreme events may not just be one event. Some of them could be a culmination of many different events. And on top of that, we may have simultaneous events, which we have on the prairies. You can have catastrophic flooding, and very close by you can have a major drought. So there are basically, the basic approaches are well known. In fact, the people apply the definition slightly different.
Just to build on that briefly, we've got a really diverse audience from transport to engineers, et cetera. And in the same way, we define many of these extremes in social terms. So for building codes for engineers, when we get a heat wave, when you trigger an alert in Ottawa and Toronto, is very different than in Miami. There it would be every day of the summer. So we do it even in policy terms a little bit. When disaster relief kicks in, it's the severity of the event in economic terms, not just in terms of meteorological terms, et cetera. So around the room, we all have to deal with what is an extreme event in different ways. And that social context is important to remember, because as we're seeing changes or observing changes in extremes, both their frequency and magnitude, our policy and our codes and other things have to keep pace with that. Otherwise, it's akin to sort of driving down the road looking in the rearview mirror. You've got clarity in terms of the climatology 50 years ago, when really what matters is what's in front of you.
Could you give us some examples of recent extreme events in Canada, and explain a little bit the reasons why those events took place? Ron?
There's a long list. I'll just talk about a couple. We're looking at the Alberta flooding right now. We have several studies going on looking at that catastrophic event of a couple of years ago. And it was a very unusual event. Other storms in that part of the country had actually produced more precipitation, but over a wider area. This particular event produced more precipitation in a relatively small area that actually led to the flooding. That's because that particular storm, of all the ones we've looked at since 1950, was the most convective. And convection means very strong updrafts, and that means you can put precipitation in very small areas. And this was the most convective one of them all. So a very important feature of that was its convective nature. The moisture from that actually came from the southern United States, which is experiencing very hot conditions. It was very moist ground, so a huge amount of hot, moist air, which is unstable, moved into the area, which we haven't seen since 1960. Looking at the Manitoba floods, we had catastrophic flooding in 2011 and 2014, and this is quite consistent with a very significant increase in summertime, springtime precipitation in Manitoba. So the first one was a culmination of enhanced precipitation over a year and a half before 2011. The 2014 one, basically, it was an innocuous spring, but we had major summertime flooding. And both of these events were characterized, as I said, by heavy precip, which was associated with very slow-moving systems, which moved up from the United States, which normally doesn't happen. So we had a lot of precipitation. And the other thing which we've done on the prairies, of course, is get rid of most of our wetlands. So in western Manitoba, we've lost 75% of our wetlands. I grew up on a farm, and so where I used to see ducks and marshes, that's all gone now. Whenever it precipitates, that runs off into the rivers. So we have two big factors, a big increase in precipitation, plus the ground is much more susceptible to runoff. Those are two examples. I could go on and talk about the Toronto rainstorm, which is a very interesting one as well, because a very slow-moving front interacted with a lake breeze coming up from the south, producing very unusual pockets of heavy precip in particular areas, and it was a coincidence of timing, a slow-moving system that actually interacted with the lake breeze coming off Lake Ontario. So if the timing was a little bit off, it wouldn't have been as catastrophic. So those are a couple of examples. Vancouver heat wave 2009 is because the sea breeze wasn't operating. And so the temperatures were allowed to get hot, even at night, with very humid conditions, and that was led to a lot of deaths, for example, in the Vancouver area. So there are many different types of recent events. Those are just a couple of examples.
And then we go into the social realm, and things sometimes get even more complicated, sort of what translates into a disaster or a major event in social economic terms is partly driven by what happens in meteorological terms for the extreme events, but also then we have to look at what we sometimes refer to as a sort of social autopsy of an event. Was it our engineered systems that broke down? Was it our communication systems, the warning systems that broke down? Were there social networks? What caused things? And we've looked at that in different parts of the world after events like that, and we've learned a lot. In some cases, like the Chicago heat wave, even one neighborhood next to another, both exposed to the same things, one an African-American neighborhood, one a Latino neighborhood, and the number of deaths turning out to be fundamentally different. Why? The social networks were different. So the engineering and other things were the same, it was the social connections that were different. And that's one of our key roles as social scientists, is after every one of these events happen, learn from it. And we look at the ice storm that hit here in Quebec in 98. The engineers learn from it, break away arms on their big towers so that those things don't come down. You don't have to replace them all. Farmers, and talking to one of our CBC colleagues yesterday, you know, the backup heat generator, that resilience that people experienced from that event is still with them today. So that's an important sort of social learning component. So
do you think Canadians know enough about extreme weather in a practical sense? I mean, are we educated enough in this area?
I can start with that one, maybe. We like to talk about it, as you said, so there's no shortage of that around the Tim Hortons tables in the morning. One of the things that we really sort of promote, and we've seen that in the States too, when they talk about weather resilience, they have a Resilient America program, and they have 4 pillars, one of which is public knowledge of what they're at risk to, so knowing where they're situated, what they're at risk to, and what do they do about it when they see a warning, how do they protect their house. Putting a backup valve in your basement, either a new house or a rebuild, is something that the vast majority of us don't have, but it's a $400 to a $2,000 part that can save you, hundreds of thousands of dollars in damage potentially. So we need to know more about what we're at risk to, what we can do as homeowners about it, but also how do we work with municipalities and governments as well. And so one of the programs we started to pilot at Waterloo is something called the Home Adaptation Program, where we take people through, look at their home, what can they do about it, educate them about their insurance, because as we saw in Calgary, that was a real sort of reputational risk for you as politicians and other decision makers, the insurance industry as well. People thought they were covered for certain things. It turns out maybe they weren't. And so people need to be knowledgeable about what they're insured for as well. So that's a program, and some of you may have been part of the pilots already, where we go in, talk to the homeowner about their insurance, what they can do about their home itself, what to do in an emergency, and other sorts of things. So it tries to address some of that knowledge deficit that we have as individuals.
In terms of the physical scientists, I think we're just scratching the surface. I led an initiative on drought over the Canadian prairies. There were 30 of us worked for 6 years on one drought, 1999 to 2004. And after the end of it, I think we really just scratched the surface on what a drought is. And another example is the Alberta situation. One can just say it was just bad luck, because other storms, as I said, actually produced more precipitation, and you could just say it was bad luck, it happened to be there. But we really have to understand why the nature of the internal structure was different. It was different than the other ones, and we don't necessarily understand that. I've told you it's a convective one. We have to understand that. Another example is the forest fires in the Northwest Territories in 2014. When you have a major forest fires, we know the major ingredients for that, but there's some interesting feedback mechanisms are operating. One of them is the generation of positive lightning within the storms acting to perpetuate the drought and start new fires. And it's actually because of not just lightning, but positive lightning. And we believe the feedback mechanism is actually linked with the smoke within the fires themselves. You're talking about ice storms, for example. We have to better understand the southerly flow down the north side of the Appalachian Mountains in the Montreal area in particular, because that downwards flow actually enhances the inversion to produce more freezing rain in the Montreal areas. We have to understand that better. And so I could go on and on as well. So those are, in terms of the physical understanding, we still have many issues as well. And we're looking at an event that was a major flooding event in Winnipeg this past summer in August of this particular year. It was very similar to the Toronto situation, but we didn't have a lake breeze. And it produced all sorts of major flooding at 200-year return periods of precipitation right within the Winnipeg area. So we're sort of contrasting that against the Toronto situation, which had the added impetus of the lake breeze, but in our particular situation, it was the same equivalent return period, but without that lake breeze. So we still have to understand that.
So perhaps we should talk a little bit more about impacts, costs, cost to taxpayers, cost to government, surrounding these extreme weather events, and you can use some examples from Canadian extreme events, perhaps. Dan?
Yeah, so I mean that's partly the bottom line in all of this. So I'm going to answer that in sort of two parts. At the macro scale, insurance is a really good indicator for us as social scientists, because as money changes hands, you have a record of that thing. Other types of impacts are much less well monetized, so they're a bit more difficult to put in a broader social cost context. But the insurance, what we see at a global scale, the reinsurers, when they trigger a payout, the number of events that they're responding to has increased to roughly 200% to 300% since 1980. So they're seeing the number of events that they have to respond to increase substantially as reinsurers. And when you look at the regional data, North America and Australia are the two that are sort of leading that increase, much of that being our neighbors to the south being hit repeatedly with different events. When we come down to the Canadian context, from the insurance data, we can see from the 70s up until about 2005, we only had 5 events that sort of tipped over about $500 million. But since 2009, every year has been above $1 billion. So we're seeing a step change there as well. Will it continue that way? We certainly hope not, but that's an unsustainable trend. And we even see that in terms of the taxpayer liability. When you look at disaster relief costs, we used to average in the 70s through the early 90s about $10 million a year. Now we're $200 to $300 million a year the last couple of years. So that's a 20, 30-fold increase that as the federal government and other governments are paying similar sort of maybe amounts on provincial and municipal costs, that too is an unsustainable trend. So we have to look at how do we reverse that. We hope it doesn't happen. So those are some of the big picture macro scale costs. Those of you who are from ridings that have been hit by events in the last 5-10 years will have witnessed this, that there's a lot of micro scale impacts that we as social scientists try to get a handle on, and that aren't as well monetized. So mental health. Some post-disaster studies are showing mental illness goes up 10 to 15%. So that's in our healthcare system. The severe or serious mental health diagnosis go up 100% in some cases. So those are the sort of debilitating ones that prevent people from working. So that shows up in your safety nets of various types that we often don't account for these things. Families, small businesses, you've got concentrated assets in small places, limited reserves to buffer yourself against. We've seen in the States some families who were underinsured or not insured had to put a roof over their heads, so their kids' education fund had to be spent or their retirement fund had to be spent. So those have longitudinal costs on those families and our social safety nets that we don't account for well. So we know the cost to society, the social cost to taxpayers is underestimated. We just can't say by how much.
I may not be able to give any monetary numbers, but I'm involved in a study right now. We're reviewing the literature on the health impacts of drought across Canada. So there's 2 physical scientists and a number of medical scientists listing all across Canada some of the huge number of health impacts. I know growing up on the farm, I assure you, the mental anguish of drought because your crop is withering in the fields. Another thing I was surprised at was the Vancouver heat wave. As I said, we have economists working on that, and they really have very little literature on the economic impacts of heat wave, not just in Vancouver, across the country. And in fact, we've been talking to BC Hydro about the increased utilization of electricity. It isn't as much as a cold spell, but it was pointed out, I believe most of those condos in Vancouver don't have air conditioning. And they have windows which open only a little bit because of the safety issues, so they become blast furnaces in these kind of heat waves. So the concern is whether they will convert to more air conditioning or whatever. So there's an interesting issue. When I was in Yellowknife 2 years ago at a forest fire workshop, I was astounded by the impact of forest fires on the Northwest Territories, and that certainly includes air quality issues as well. Every sector of the Northwest Territories, and my understanding, I could be wrong, is that forest fires for climate change is Northwest Territories one of its biggest concerns as well. And I've done a lot of work in Eastern Canada looking at your major storms there as well, and I'm sure this year is much worse than other years as well, but the impact of that is full of a huge amount of anguish as well. So I don't see any event that doesn't cause major impacts. Sometimes it's not necessarily just the event, it's some subcomponent with it. For example, freezing rain is one thing, but freezing rain with wind is actually very often much more impact. So you really have to understand not if it's going to be freezing rain, but whether it'll be strong winds after the freezing rain, not before. So the physical scientists, we have to deal with those kinds of issues as well. So those are just a few, maybe not anecdotes, from the physical side as well. Thank you.
Wow, and we thought that a condo in Vancouver was expensive now, if they have to be all retrofitted. So let's move on perhaps to things that we can do to help mitigate and prepare populations. Are there any policies that might be worth considering to be put in place, either nationally or provincially or at the municipal level? Dan?
Sure, I'll maybe start with that one. So at Waterloo, we've worked. We had a roundtable last year with insurers, real estate developers, municipalities, provinces, etc. Asking some of these questions. What are some of the priorities that we can look at in terms of weather resilience? Cities came out on top as one of the big things. I think everybody around the table here, we've got a diverse audience, can all agree. Dealing with weather extremes is everybody's business, so it's not down to one stakeholder or another. We've got to figure out what is the best way to coordinate some of these things. we can all probably agree that infrastructure is part of the problem, it's part of the solution as well. So part of the problem, we've got infrastructure deficit, we're trying to work through to work through that. That's causing municipalities some consternation in some places, in that recently we've seen a number of storm events. Thunder Bay, Mississauga, Stratford are all being sued by their residents, and in some cases insurers, for not properly maintaining their systems. And so sewer backup causing damages, and so they're being sued by their own constituents in some cases. So how much investment is enough? I'm sure we get a range of views across this room. So what programs need to be in place for that? Do earmark components need to be for weather resilience? That's partly something that we can discuss. One thing for the New Build Canada program that I'd love to see is that every project that's funded by it passes what I would call the sort of future climate test. So whether it's designed specifically for weather resilience or not, it looks at what are we anticipating coming over the lifetime of that project, and consider some of that uncertainty in terms of the design, so that it doesn't become part of the problem 10, 20, 25 years from now. It stays part of the solution. So that's one. Building codes is another that David and other engineers can talk a lot more as well at a federal level. One of the things I'd like to see more conversation about actually is a national overland flood insurance program. There's been some early discussions about interest in that from the federal government, the province. The insurers that we work with are all interested in being part of that dialogue. That, I think, needs to be accelerated a little bit, because last month we had a bit of a game, what I would call a game changer. So Aviva is one of the insurers who is now saying we're going to offer overland flood insurance in Alberta and Ontario as of May. And that, you can say, well, that's great. If you're one of those homeowners in Calgary that were flooded last year, what's your mortgage lender going to say? You need that insurance. The same way you have fire insurance, I want you to have that flood insurance. What if it's prohibitively expensive? We don't know what the cost structure is going to be. So when we talk to some of the insurance R&D guys that we work with, they say, how are they going to price this? We have no idea. The absolute sort of knowledge foundation that we need for it is up-to-date and consistent or standardized flood risk maps, and Canada doesn't have those. Ontario's, some estimates for their flood risk maps are 50 to 80% are out of date. So how are you going to price that insurance? And so that, even going future, if you don't have that flood insurance, will you still qualify for disaster relief? And if so, why would you ever buy that insurance, right? So these are some of the things we have to work through. Aviva's come to the table and they've taken a good, positive first step. It's a bit of a game changer, but without a game plan to go with it, I think it could cause some potential problems going forward. So that's one, I think, that needs a little bit more dialogue at a national scale.
I'll just add a couple of different things. In terms of this particular question, the other thing is to, of course, be able to really monitor these events and their structure. And, of course, if you're warned better, in other words, better prediction, I think, can only be of assistance as well. And also just increase the awareness. Just because an event didn't happen with you, it may happen tomorrow. I remember I was living in Toronto during the 1998 ice storm, and I just remember the fact that we were very lucky that we didn't get an ice storm. And sure enough, a number of years later, Toronto did get an ice storm. So just an awareness, just because your particular location didn't get it this time, learn lessons from the people who have, I think. So there's monitoring, better prediction, and also just awareness and potential expectation it might happen to you later on.
Just to follow up on Ron's point, one of the things that we heard from our sort of multi-stakeholder roundtable was that, and it sort of builds on some of the things that have been done in the States as well, is sort of a national assessment of city preparedness, starting perhaps with some of the bigger ones. But I'd also argue we hear more increasingly in the last couple of months, we've had rural and small municipalities come to us and say, we need help on some of these things. We don't have the capacity. This is coming from Atlantic Canada, but Ontario as well. Can you help us with some of these things? So that sort of national assessment of urban, but also other preparedness might be part of that same discussion.
Are there any countries that you can look to that you feel are doing a good job in this area? Or are we all kind of, moving erratically into a new world?
No, that's a great question. And yeah, we're all muddling through this together. Things like coastal setbacks. How do you implement going from a 1 in 100 to a 1 in 200 year flood line, for example, causes a lot of consternation if you're now inside that line and you have to pay flood insurance that yesterday you didn't have to. The U.S. has gone through some of that, so there's some really good lessons for us of what to do and what not to do in terms of how do you communicate that with people so that they know. And if you go right now, we can go to FEMA and say, pick an address in San Antonio, and you can say, am I in a floodplain? And is that flood line going to move within the next 2 or 3 years? So you can anticipate it at the property scale. That's something we absolutely don't have. But if we're going to have flood insurance, overland flood insurance in this country, that's the type of information we need to move to. So we can learn some things from FEMA and some others. We can also learn some things not to do from FEMA as well, as many of you all know. But there's 2 initiatives that I would point to that are that will give us something to build on. So there's something called Resilient Australia, and then the Resilience America Resilience Program that are grappling with these sort of extremes of various types and what can be done about it. As Ron talked about, lessons learned from one community to another. How do you pull those together and have one municipality sort of peer-to-peer teaching another what worked for us and what didn't? So there are some things that we can learn from and build on, I think.
In terms of the physical scientist, there's a number of other countries around the world which, of course, are affected by extreme weather. And for things like drought, for example, we participated in international scientific activities on the science of drought. And it's very important for us to do that, to not only understand drought actually has different manifestations, even meteorological drought, and the contributions we can make to the International Forum are extremely useful, and vice versa. But we have a lot of important characteristics. I think we actually have a role in Canada to examine our extremes, because the world looks to us for cold extremes and looks to us for extremes which are nudging their way north as our climate does, for example. So the world looks to us for these kinds of things as well. So we can learn from other ones, but there's an expectation from the rest of the world. Like forest fires, for example, in Northwest Territories, there's a whole issues of permafrost. There's all sorts of interesting feedback, very important feedback mechanisms that we have a role to play in those events. Catastrophic events like we have on our East Coast, that's a natural niche for our scientific objectives within this country. So we learn from other countries, but we can contribute as well. We do contribute.
Thank you. I think perhaps it's now time to ask the audience to pose some questions of our speaker, and I'll ask Antonia to take over here.
Thank you, Francis. You can sit. I'm sure you can answer some of these questions as well. Now is time for our Q&A session. The mics are there. Oh, there's just the one, so you'll have to queue up. Alors, vous pouvez poser vos questions en anglais ou en français, et je ferai mon mieux pour traduire s'il faut. Comme on est au Parlement, on va avoir les règles de la Chambre de communes. Vous avez 30 secondes. Ouais. Okay, we're in the Parliament, so we're going to have House of Commons rules, which are often hard to impose, even in the House of Commons, but I will do my best. So if you could just introduce yourself first, say who you are, and your question, short question to either or both or all 3 of our speakers.
Okay, I'm Rod Story. I'm with the Parliamentary Budget Office. A question I think is probably for Daniel. You mentioned that Aviva is offering flood insurance. How are they getting around adverse selection? Because that's one of the major problems is only the people that truly need it want it, and those who don't, and it's too expensive, nobody ends up buying it.
Yeah, that's the whole point of the great question. That's the whole point of insurance is you're trying to spread the risk. Right now, it's early days. There's a lot of uncertainty when we talk to their competitors. They're perplexed is the word they would use. Their concern is they're going to do exactly that. They're going to cherry pick. You're sitting up on top of a mountain. We know you're not going to be flooded. We'll sell you insurance, but the people who actually need it, what are they going to be priced at? Part of what they're doing right now is they're bundling it with their other water, so sewer backup and wind and some of the other things that they. So the only thing they don't cover in this new package will be storm surge. So Atlantic Canada will still not have some of the types of water damage that they see covered by this. But that's partly why I think there needs to be a dialogue on this. If they just cherry pick the ones up on top, they're actually going to take premiums away from the other insurers who may be covering the more at-risk properties in the future. And then that's problematic from a risk spreading perspective.
Good morning. Dennis Bevington, Member of Parliament for the Northwest Territories. I appreciate the effort that you put into talking about the Northwest Territories, because we're looking at another drought season this year with the same problems with forest fires. And my question is more about the impacts of climate change on our weather systems. We've seen that in the U.S. there's been a lot of research on the movement of the jet stream and the issues that potentially is causing to our weather systems. Our weather systems determine almost everything that we do in our lives, how well our economics work, how well our communities work. We base that. So what's going on in Canada to really understand how these system changes are going to play out on the ground? Is there a body of science that we can refer to that is doing this work, that is making this effort for Canada?
Well, I can start that. Yes, there are a number of people in Canada addressing climate change within the government and the academic community. You're absolutely right. I mentioned these Manitoba flooding situations, and they were characterized by very slow-moving systems. And that's very consistent with the hypothesis of a warming Arctic. And if you have the warming Arctic, basically the temperature contrast between the Arctic and the more tropical regions is decreased. And if you have a reduction of that, that decreases the winds and the steering mechanisms for the storms. And furthermore, the flow fields are more accentuated as it goes around the poles. So what we saw in Manitoba is consistent with that. So that's one example. And the other thing, you probably heard a lot of press about the California flood. And in fact, a lot of the drought in the Northwest Territories is actually part of the same system. And there's a concern that this may be very much a harbinger of climate change as well. But I would almost argue that every storm system is now affected by climate change. We've gone from the carbon dioxide concentrations of 280 parts per million in the pre-industrial period to 500 now. So our climate has changed. We have not quite a doubling of the CO2, the greenhouse gases, but a long way towards that. We have more water vapor in the atmosphere, and we've had a lot of looks at trends of particular parameters across Canada, which are not inconsistent with the notion of climate change. Will those be temperature measures and precipitation measures and even drought measures as well, including the circulation fields as well. So I'm not sure whether I've answered your question enough. Scientists are generally very hesitant to be able to attribute something to climate change, whether it be the Northwest Territories forest fires or the catastrophic winter storms we've had here. But those things are not inconsistent with the notion of climate change. And maybe one of our best examples, from my perspective, may be the Manitoba situation.
And just to build on that briefly, yeah, I mean, the point you're raising is an important one, that what happens in your part of the world affects other parts of the world as well, whether it's be the sort of locking in this cold that we've had the last 2 winters here, where we don't get the usual sort of melt and we're all hiding in our igloos, wanting to. It's the scientific community is struggling a little bit with trying to understand the very localized impacts, which are the things that really matter to us on the ground in terms of social impacts. But as Ron said, there are certain things, the Australian heat wave, for example, a new report came out of their government that said that 2013 heat wave was a 1 in 12,000 event. So it's statistically, in their view, impossible without the warming that we've seen over the last couple decades. So it's important to know those regional impacts, but also how they then manifest themselves in other parts of our country and elsewhere in the world.
My name is Alan Jagan. I think you partially answered my question already. My question was about the stationary polar vortex that we have experienced during the past couple of years. Do you understand this mechanism now, and is it going to be happening again and again? And I think most of us want to plan our next winter, so it's a very selfish question, I'm afraid.
Well, the polar vortex is a natural part of our climate system. But basically, the last couple of years, depends on its location and strength. They're very critical factors. And it's actually, you can't disassociate that with what's happening in Western North America, which is basically almost the opposite, a major high-pressure system sitting over the Western United States giving unprecedented drought. So basically, if you think about the atmosphere, you have a circulation around the North Pole, which is basically the Arctic vortex, but it has variable strength. And but also where it actually occurs is somewhat by chance, but although right now it's not necessarily by chance because there's a very large circulation sitting over the Western North America, giving rise to warm air coming into that part of the country, giving rise to a lack of winter in Vancouver. So the air is coming from the south and the western part of North America, which means it has to come from north somewhere else. So these things are not, they have to occur. So basically the air is coming from somewhere, it's got to come back the other way. It just happens. So I think when you're looking at these scenarios of future drought, mega droughts in the western North America, we may be thinking in the eastern part of the country, we may have its ugly twin, which is basically more prevalence of a northerly flow. It won't be every year. There's a lot of variability in the system. But the polar vortex is a natural part of the system, but its strength varies. When you have a warming Arctic, the strength of it actually, in terms of circulation, decreases. But it's very persistent. It doesn't move very much. And the southerly edge of that cold air is where the storms operate, where the battle is going on between the cold air and the warm air. And that's the storm track, which this year has unfortunately affected eastern Canada and the Maritimes more. So it's a natural part of the system, but its strength we're very concerned with is being altered through the warming Arctic in particular by this. And also the other thing, almost as much warming is predicted to occur over arid regions, such as California. And that also leads to persistent high and perpetuates drought. The Mediterranean is actually predicted to be even drier than it is now. So I don't know if I've answered your question in some muddled way, but those are a few comments. Thanks.
But very good and important point, because that's the science of that is sort of evolving. An important part of that is about over 90% of the energy that's sort of the long wave energy that's kept in our planetary energy balance by additional greenhouse gases goes into the oceans. And so as you open up the oceans for a longer period of time, more of that's stored there. But we're also still trying to understand some of that exchange mechanisms in the Pacific, for example, taking up more heat over the last few years, but when is that going to be released, and will we get an extra little bounce in terms of global temperatures because much more heat is being taken down a deeper ocean? So it's linked, but the science is still evolving in that area.
I just wanted to add one other thing. When you do get cold temperatures like here, you do get feedback mechanisms because the ground will be covered in ice, so basically reflects more. And we've frozen the Great Lakes this year. We've taken away that regional huge amount of heat. And so basically you don't have a local heat source and you cover the ground with snow, and so that acts to perpetuate those larger scale factors as well.
I'm Reuel Amder. I write for the West Quebec, I write for Canadian Charger. The question I have is a macro one, which is what is causing climate change?
I think that's too big a question. We're going to pass. Could I ask Monsieur Blanchette, the député, to ask his question? We ask parliamentarians to ask their questions first.
Okay. Merci beaucoup. Denis Blanchette, député fédéral de Louis-Hébert pour le NPD. Je remercie les conférenciers. Ils ont juste commencé à traiter vraiment des choses qui nous attendent comme telles. Vous avez parlé d'assurance pour les inondations. C'est beau, mais est-ce que les gens ont les moyens de se payer ces fameuses assurances-là? Moi, je suis pas sûr avec le taux d'endettement qu'on a présentement. On est dans une société où les gens vivent de plus en plus seuls, beaucoup de gens qui vivent seuls. Et quand il y a des désastres importants, eh bien, ça amplifie la solitude comme telle. Donc, on peut penser que le tissu social, en tant que tel, risque de se désagréger plus vite, surtout maintenant que la vie sociale se fait beaucoup par le numérique pour certaines catégories de population. Alors, j'aimerais avoir des commentaires là-dessus. L'autre chose, au niveau physique, évidemment, il y a des moyens à prendre, mais ce que je vois, puis le problème que nous avons collectivement, c'est qu'on a de la difficulté, évidemment, à prévoir qu'est-ce qui va se passer. Le dernier hiver est un exemple. Mais surtout, on n'a pas d'idée vraiment là, d'un véritable plan de match pour être capable de faire face aux défis qui s'en viennent. J'aimerais avoir vos commentaires à vous là-dessus.
Do you want to take that first?
No.
Oh, sorry.
The first question was directed at you, Professor Scott, which is about how is life in Canada changing in the sense that we have less social resilience, in a sense, in terms of community supports. People are living alone. The kind of supports that were in place to face these kinds of issues that had to do with extreme weather are no longer there. You mentioned insurance, but is insurance really something we can count on and that people are, is that the solution that people will go to? So how do we deal with that kind of a challenge today?
Yeah, I mean, that's a very important point. And as I said, when we've had these sort of social autopsies of some events, that social cohesion for small communities, helping out other businesses, helping their neighbors out when the floodwaters are there, checking on people when the heat is there, that's fundamental to resilience. And we're seeing some of that as families, including my own, live in 3 different parts of the country. When my dad in Saskatchewan gets hit by an extreme event, I'm not there to help him, and I have to rely on somebody else. So that's a very important point. How do you build that social cohesion in communities is what we would call, social capital. That's a big part of maintaining that. So be it churches take up some of that function or other community groups, they have to be integrated in emergency planning, and so they take on a fundamental role that our family connections maybe served that purpose a little bit more in the past. The insurance is mostly there from an economic perspective, but that social piece is a massive piece that we have to look at as well.
Second question is Professor Stewart. Let me paraphrase it. When are you guys going to get better at predicting?
More grants. There's your open.
No, I think the prediction is actually getting quite good. Actually, Environment Canada is now moving towards a model which actually covers the country in 2.5 kilometer spacing, grid spacing. We're now having hourly predictions. They are getting better. But it's a very complicated world, and in terms of our climate prediction group, they're sort of ranked amongst the world as well. So we should be very proud of our predictive capabilities in this country. We stand up to pretty well anybody. Obviously, we could use more research in that sense. Would help a lot. Well, actually, and even just the monitoring, our monitoring networks in many ways aren't able to even capture what some of these events actually are. And models need to initialize the state of the atmosphere before they can predict. And we often have a deficiency of information just characterizing the atmosphere and associated surface in order to predict better in the future. And in fact, and I will say, we certainly need more research. There are actually very few people in this country actually studying the science of these major events. I can put in a handful of universities, for example. Environment Canada and some of the other government agencies have their capabilities well, but it isn't a very big area, and I don't mean to just harbinge that, but I think that more research would be useful. The United States, when an event happens, they have a huge activity on that. There's a few of us looking at the Alberta flooding, for example, just a handful of people, like 4 or 5 people, that's all there is. The Manitoba flooding is just 2 people looking at that, and so there aren't many people. So I think more focus on the basic science like that to be able to tell the predictive community what actually is key is really important, actually. So.
Just to touch on that as well, even as social scientists, when we're working with the insurance company, for example, or a group of them, the Alberta Hail Suppression project, they wanted, is the return on investment worth it and does the science prove it? And we can't say for sure. Part of what we say is we don't have the mobile radar units to actually do it, and then they're willing. So that's an example of private-public partnership that can come to play. They're willing to get us that unit so that we can actually do the science with Ron and others and then translate it into the economic terms. So that's an example of where things can move ahead, but where it's sort of linked to a very specific activity.
I'm Marianne Wilkinson. I'm an Ottawa City Councillor and I'm in Canada North, and I'm dealing with a very large new development. How do you handle stormwater? And you're talking about the infrastructure deficit. We've had 3 100-year storms in the last 5 or 6 years. They're not 100-year storms anymore. And how the difficulty is the developer wants to put the least amount of money into doing it. The city spent 4 years doing 2 major studies, but that just tells us what we have now. How do we take that? And is there enough evidence to show what we have to do so we don't have what you said in your speech in 5 or 10 years, it's not working anymore? We've had serious flooding problems in those areas already. We don't want to have it again.
Yeah, I mean, at a new subdivision level, you have the benefit of being able to do some things that a 50-year-old neighborhood, it's much tougher to retrofit. So, a lot of Ontario subdivisions now put in the big stormwater retention ponds like the one out behind us. Well, it certainly helps, particularly with flash floods, because the water has somewhere to go. Older neighborhoods disconnecting downspouts and other things. How do you deal with the uncertainty of
what's
where
coming?
Where there are techniques to sort of look at it. We can't, as Ron said, give you sort of one answer now, and anybody that does, don't trust it. Because it's not there yet. And so we can give you that sort of uncertainty range, and then how much, David and others can say, well, how much additional engineering do you put into that so that you have a 10% buffer or whatever? That sort of comes down to the cost piece. But we can't, at this stage, particularly at the local scale, give you one number. One thing you can use that we've talked to others about is take an analog event like the Toronto storm, for example.
We take our own storms. We have big
if you've had big enough ones, yeah. But you can take somebody else's big storm and put it on your neighborhood or in your stormwater engineering system and see what happens. Could it have coped with that? Because that one could have hit you just as easily as it did Toronto.
We did that with a big storm we had last year for the modeling we did on what the present situation is. So that did show us what that was. So there's a lot more work happening now. But was that buffer going to be a 10% or 30%, or what we have to do to make sure these things in the future somebody can concentrate on the downtown Ottawa, which is costing us a small fortune to deal with runoff.
You're right. You do your due diligence in that way. And one of the things that I'll talk about at City Hall later is that sort of liability factor. You've taken it into consideration. You've done the best you can from a science perspective. Somebody can't come back and sue you in 10 years because you didn't at least take it into account and do something about it. And that's the important thing to do from a municipality.
Yeah, we don't want any more suits. We've got a few of them already.
There's enough of those, yes.
Good morning. John Lark from Coherent Advice. I'd like to speak a bit on behalf of the resiliency of humankind and their willingness to make these investments. That as a Brandon boy myself, I look at the floodway, which was built in 1950 in response to the 50 flood, which today still protects Winnipeg. But I was astonished to find I couldn't buy flood insurance, even though I was inside the floodway when I lived there. And during the Katrina flood, they interviewed a scientist from the Netherlands about the disaster in Katrina, and he said it's all about risk tolerance. You built a dam to withstand a 1 in 150-year flood, and you got one. And we build for 1 in 10,000 years. Yeah. And as a society, we spent $1 billion to build gates to close the mouth of the Rhine River in case there's a surge. That if you're prepared to make these kinds of investments, then society can become resilient. And the conservation authorities in Ontario were to manage watersheds after Hurricane Hazel to prevent flashiness in watersheds. So I think with information, society is prepared, if they understand the risk, to make these, in some cases, massive investments to become resilient.
Yeah, a great point, and the business case is there, and the U.S. has seen that when they've done the return on investment of disaster prevention. On average, across a range of hazards, it's 4 to 1. And then if you look at, even I wrote in a book, even I knew engineers saying that New Orleans was going to be hit and it wouldn't withstand a Cat 4 or 5 hurricane. Even I knew that. The bill to build it up was $4 to $5 billion. Now the U.S. government has paid $160 billion Katrina recovery. So that's not just New Orleans, but orders of magnitude above that. So that's part of what we need to do a better job of is show the return on investment. And we know it makes good business sense. Protect the economic assets that you have and don't put new ones in harm's way. But we need to do a better job of detailing that business case and communicating that to taxpayers who are the ones that have to vote for that resilience as well.
Okay, one last question. Thank you.
Thank you very much. Neil Maxwell from the Office of the Auditor General. Much of what you've talked about are things that need to be done by municipalities, provinces. So as you think of what the federal government does and all that range of things, research, prediction, emergency response, financial assistance after disaster financial assistance, is there one thing more than anything else that you think the Fed should be doing better?
Wow. Can I say more than one thing?
That's the chair's prerogative.
30 seconds.
In 30 seconds.
Parliament of Canada.
Yeah, I mean, when we hear from our range of stakeholders, they all realize they all have a place to play, and they all have different jurisdictional responsibilities. Some of it's, particularly smaller communities and others, just don't have the deep pockets on the infrastructure side. So that's definitely one area where there has to be that working with the federal government. I would argue, and it's maybe a bee in my bonnet, but the National Flood Insurance Program is an excellent place for the federal government to ensure standardization so that we have a sustainable and competitive insurance market, because right now in Atlantic Canada and other places, it's a broken business model. It's unsustainable, and that can't continue for very long. So that's a place that I think the federal government can show some leadership as well as my sort of maybe top two.
Well, I'll just reiterate something you've already said. I think our monitoring systems, although certainly fine, they could certainly be better. For example, in the Alberta area, the closest radar is like 120 kilometers away. So basically, for actually having information on the heavy precipitation in the generating area for the flooding, we actually have very limited information. That's just one example. So improvements in infrastructure for monitoring would be very useful. And I don't know who has jurisdiction, but actually just the coordination of information, maybe the national perspective would be very useful. It's not just national governments have monitoring networks, municipalities do, and cities do, and provinces do, and just merging those together. I don't know whether there's been national forums on natural hazards, for example. That would be very useful. The United States is very good about doing this, and I don't know whether we've done that before. From the physical side, I'm not aware of anything. That might be a very useful thing. And bringing people together. There's a big workshop next month in drought in California, which is bringing everybody together, from the little old physical scientists to all of those affected, and working together to get a sense of community. And because the people affected have a big impact on what the physical scientists do, and vice versa. I don't know whether we have that collective national sense of community to address these particular issues. So those are a couple of things that off the top of my head. Thanks.
Thank you. Thanks to all of our speakers, Dr. Stewart, Dr. Scott, Dr. Pick, and to our sponsors, the PAGC. The Federation PAGC have come together for this talk, and this is the reason why. To have social scientists and scientists talk to one another and to us to help us understand these very complex issues crystal clear. Thank you very much for your insights and also for the great moderation. Thank you. I wanted to have a couple of closing remarks to thank not only our sponsors, PAGC and the Federation, but also Engineers Canada and the University of Manitoba. And I also wanted to let you know that there's a second event that's happening this morning that's related to extreme weather. I don't mean the extreme weather outside. I mean talking about extreme weather. Just I'm not going to predict that today. On the Hill, it's at 12:30 in room 238S in the center block. And Engineers Canada will be hosting some talented engineering students and a few parliamentarians, who are also talented, of course, who will be challenged to build a resilient structure. So it's a kind of engaging, hands-on kind of an event. And it's an opportunity, I think, for all of us, and especially for Engineers Canada, to share some of the exciting news about work, what the engineering professors do to help engineers, and also how we can get additional skills and knowledge that's needed to improve the kinds of infrastructures and other vulnerabilities that we've talked about today. I just wanted to thank, he's had to leave for another meeting, but James Rajat, our parliamentarian, who is the sponsor of these events for us, for allowing us to use this beautiful parliamentary restaurant. Et c'est grâce à Monsieur Rajat que ces événements peuvent se tenir ici au Parlement. On le remercie très chaleureusement. Merci encore au CRSH, au CRSNG, Canaries et d'autres pour leur soutien tout au long de cette série. And I thank you all for making this a real conversation. Thank you, Francis, for really bringing us in to the weeds, but helping us understand what's going on in extreme weather and climate change. A reminder is that the Federation brings big thinking not only to the Hill, but also to the Congress of the Humanities and Social Sciences, which this year will be held just across the way at the University of Ottawa, and you can find out more by picking up the literature and brochures at the registration desk. We actually have our next event, the Big Thinking series, is another Bacon and Eggheads event. It's on the Hill on April 23rd, and Dr. Jerry Wright from McMaster University will address the crisis in antibiotics. So again, another way of addressing some of these issues from both a social science and a science perspective. It's been a wonderful talk. Merci beaucoup et bonne journée à tous.